Dear class, good morning and welcome to this class, geomorphology for today. Remember last time when we met, we were looking at, we discussed several issues as far as geomorphology is concerned. Today I want us to have a discussion. In this explanation, I'm going to give you information on the domains of geomorphology, or what we refer to as approaches to modern geomorphology. Geomorphology approaches to modern geomorphology. Geomorphology Modern geomorphology study basically what we call three aspects of landforms, i.e. we have form or structure, we have process, and then we have time, or what we refer to as history. And therefore, out of these three aspects of landforms, we derive the three main domains of geomorphology, i.e. number one, we have structural geomorphology, which studies structure or form of landforms. Structural geomorphology refers, or these are people who argue that the underlying geological structures are the key to understanding many landforms. To them, local structure is a key aspect as far as resistance of the surface to processes of weathering and erosion is concerned, and therefore in the end it influences the rates at which these processes operate. So like when we are talking about weathering processes and we talk about the nature of the parent rock, under this structural geomorphology, these are people who pay emphasis to the structure of the rock and how it influences the rate at which the weathering processes and other processes operate on these landforms. So therefore, to them, they say landforms reflect the nature of the underlying bedrock, i.e. rocks which are resistant to erosion survive and form uplands like hills, while less resistant rocks are eroded and form low-lying features like basins and valleys. Remember even when you are discussing local resistance, we usually talk about, for example, these intrusive igneous features, like dikes, which are discordant features. If they are made up of high resistant material, then denudation will occur, but eventually because the material is resistant, they lead formation of wall-like features that rise way above the surrounding landscape. But if these rocks are non-resistant, then they form trenches. So that's what we are just simply referring to here. If the rocks are resistant, then you know you're going to have uplands. That's why we have inselbergs in these areas of northern plains of Uganda. These are plains, you know, when you talk about an inselberg, an isolated hill within an area of larger mountainous terrain, it implies that that inselberg, for it has a certain degree of resistance as far as erosion is concerned. The term structure is used to refer to all ways in which the earth's materials out of which landforms are made differ from one another in their physical and chemical properties. That's why we talk about things to do with jointedness, we talk about texture, we talk about color, we talk about mineralogy. This is structure of the rock. Then the second domain of geomorphology, we'll look at process geomorphology. And the process geomorphology derived from the term process, on the other hand, which is used to refer to the many ways by which the Earth's surface undergoes change. Geomorphic processes have their makeup of landforms, and therefore each geomorphic process develops its own characteristic landform. This approach emphasizes the study of processes that lead to the current or historical landforms that we see today. And therefore, for process geomorphology, the focus is on the forces that modify the surface of the earth, e.g. the work of rivers or water, the work of glaciers, the work of wind, the work of waves, weathering, mass wasting, etc. The detachment process, for example, the transportation and erosion by water, wind, and ice may result in formation of erosional landforms. Glacial erosion will result in formation of glacial landforms. Wave action will result in formation of wave, either deposition or erosional landforms. So to them, different processes shape different landforms. Processes such as faulting and volcanism, which originate from within the Earth's interior, and therefore we refer to them as endogenic processes, and others such as weathering, which occur on the surface of the Earth, so we call them exogenic processes. All these ones are the focus of people who study process geomorphology. Number 3, we talk about historical geomorphology, i.e. we are talking about the nature and the rate of geomorphic processes, the rate at which they change with time. Here, in historical geomorphology, we are talking about time. Time is a very important aspect as far as landform evolution is concerned. That's why even someone like Davis came up with a classification of landforms based on age. That there are landforms which are in the useful stage, there are landforms which are in their mature stage, there are landforms which are in their old stage. So the rate at which these geomorphic processes change with time is the focus of historical geomorphology. In the high latitudes, for example, many landforms are remnants of the quaternary glaciations. In some parts of the world, existing landforms were formed millions and hundreds of years ago. That's why in geography, geology, we have that geological time scale. We know there are landforms which are of Precambrian era. But up to this day, if you come across them, then they are remnants of what was formed in the Precambrian era. We have landforms which are of the Cainozoic era. We have landforms which are of the Mesozoic era. So all these ones, for example, when you look at the Mount Elgon here and Mount Rwenzori, these mountains have different eras. In terms of age, Elgon is an older mountain from the evidence that has been brought forward by geologists. And also just by observation, you will see that Mount Elgon is an older mountain compared to the Rwenzori mountains. So under process and historical geomorphology, we look at time. As such, therefore, we say landforms possess distinct characteristics depending upon the stage of their development. Mount Elgon, which has been attributed to the Mesozoic era, has different characteristics. Look at the nature of the slopes of Mount Elgon. There are slopes and the nature of the soils. You look at, these are areas with thick soil layers. You go to Rwenzori, the soils are quite thin. So you look at areas with concave slopes, others with convex slopes. These are all attributed to the stage at which they are. You come across places like when we talk about a peneplain in northern Uganda, according to Davis, that means that area is in its old stage, the final stage of landform formation. As argued by the American geomorphologists, for example, the landforms develop in stages, since we have youth, mature, and the old stage. However, the golden rule of historical geomorphology is that the past is the key, the present is the key to the past. You look at something today and you're able to tell how it was several years ago. And then lastly, or the next one, we have fluvial geomorphology. This one, just like the name suggests, pays attention to landforms developed by flowing water, landforms that result from the work of rivers or streams. Streams of all sizes have they perform these basic functions. They move water, they move sediment, and any other form of matter from higher land surfaces and ultimately deposit these materials into lower ends. Then the next one, we have climatic geomorphology. This one brings in the aspect of climate as far as landform evolution is concerned, i.e. the study of the influence of climate on landforms. It is an appreciation that world climate is necessary for the proper understanding of the different geomorphic processes, because different climatic regions experience different geomorphic processes, and therefore climatic geomorphology pays attention to the impact of climate. There are many landforms that can be described based on the climate of a region. Glacial features are associated with temperate regions. Sand dunes are associated with desert regions. Weathering processes are associated with climates of different nature. If they are if for example physical weathering, we know very well that is very predominant in areas of cold weather and areas of too much heat. That's why we have physical weathering. Then we have chemical weathering predominant in areas of humid tropics. So all these ones are important. For the part of evolution of landforms, I already gave you this information. I told you to watch the video and then make summaries. There are criticisms of the cycle, which you can also read. Then we have Penck's concept of evolution of landforms. You know Walter Penck, for him, he tried to modify what Davis had put together by looking at his weaknesses and trying to make sure that he accounts for those weaknesses. For example, Penck, for him, argued that the primary contour of landform evolution is the relationship between the rate of tectonic uplift and erosion. So you also read about Walter Penck, and then the three types of slopes that are produced by erosion as put forward by Penck, where he said that we have uniform and straight slopes, we have convex or waxing slopes, and then we have concave or waning slopes. All these ones resulting from erosion as far as Walter Penck is concerned. So this part of it, it's going to be self-study. Maybe I'll send you some questions to cater for that. But today, for this morning, I want to explain something about rocks and the structure of the Earth. You know very well that the Earth consists of three main concentric layers, where we have the outer crust, which is the solid part of the Earth and also the smallest. It's very thin, about 40 kilometers thick, compared to other parts of compared to the Earth's radius. This crust is made up of fairly dense rock, and then we have the upper layer, which is made up of lighter rocks forming continents. The lower layers of the rocks are described as the oceanic, what we refer to as the simmer, and then the upper overlying rocks are known as the seal or the continental crust. So the crust is made up of both what we call the oceanic crust, which is dense, and then we have the continental crust or the seal, which is lighter. Then the second layer is the intermediate mantle, we're making up the largest section of the Earth. It's quite fluid and semi-mobile. Then we have the inner core, where the rocks are with a combination of minerals are formed from one or more elements. Granite, for the inner core, I beg your pardon, the inner core, which is the other part of the Earth. But we know very well that the Earth is made up basically of rocks. You know, when you're explaining the concept of the Earth, I would refer you to the analogy of an egg. Probably you guys, you can go and look out for an egg and you see how an egg is made up of three layers. Let's take the case of a boiled egg. Get a boiled egg and cut through it without removing the shell, and you'll see that it has got the three layers, which quite openly explains the structure of the Earth. That the shell is the crust, is also the smallest part of the egg. Then we have the egg white, which is the mantle, which is the largest part of the egg. Then we have the yolk, which is the core. So that egg can explain the structure of the Earth quite frankly, quite easily. But we shall explain the structure of the Earth quite more as we go ahead. But since we have said that the structure of the Earth is made up of rocks, then we need to define what rocks are. We say rocks are a combination of minerals which are formed from one or more elements. For example, granite, which is largely a mixture of minerals of quartz, feldspar, and mica. Rocks are classified according to in two ways, i.e. according to their origin and according to age. When we classify rocks according to origin, then we have rocks in the different categories. One is the volcanic rocks. These ones form at the surface of the Earth as a result of extrusive volcanicity. But these volcanic rocks are also the ones we refer to, or which result from cooling and solidification of magma. We have the hyperbasal rocks, which are formed at shallow depth under the medium rate of cooling. And then we have plutonic rocks. These form at greater depth under shallow, slow cooling conditions, resulting in rocks with large crystals. Further classification of rocks according to origin or mode of formation, we have what we call igneous rocks. And we say igneous rocks are formed by solidification of molten rock, either by intrusion or extrusion. In other words, igneous rocks are also the same as the volcanic rocks. Igneous rocks are usually classified into three subcategories. We have the extrusive igneous rocks, we have the intrusive igneous rocks. Extrusive igneous rocks, these are the ones which form as a result of extrusive volcanicity, i.e. they form at the surface of the earth, and because they are forming under processes of quick or fast cooling of magma, they are usually associated with fine texture. There is no time for crystallization to take place. So you'll find that these rocks are fine textured rocks. Then we have the intermediate igneous rocks. These are the ones which form at shallow depth, where material cools at an intermediate rate. So you'll find that there is some level of crystallization. So they are associated with crystals. And then we have the plutonic igneous rocks, which form at greater depth. Here cooling takes place very slowly, and therefore there is time for crystallization. The material has time to crystallize, hence forming big crystals which can be even identified with our naked eyes. Those are the three subcategories of igneous rocks. You know very well that igneous rocks also sometimes we refer to them as fire-formed rocks because they are formed under conditions of great heat. You know, when a volcanic eruption is taking place, that is fire. So the fire-formed rocks, magma is extruded or intruded into the crust or onto the surface of the earth and it solidifies to form rocks. Those are the ones we refer to as igneous rocks. We have sedimentary rocks that are formed by breakdown of pre-existing rocks. That rocks which have already been formed, for example, already existing igneous rocks, undergo processes on the surface of the earth. Now here we are talking about denudation or exogenic processes. And these rocks are broken down into small fragments, and then these fragments are carried into an area. They are piled up to form sediments, and then they form layers. Subsequent erosion and deposition forms another layer. So you find that these rocks are formed in forms of strata, and that's why sometimes we also refer to as stratified or derived rocks. Derived because they are derived from already pre-existing material. Sedimentary rocks are also categorized into three subcategories. We have mechanically formed sedimentary rocks, we have organically formed sedimentary rocks, and chemically formed sedimentary rocks. Now you realize that this classification also derives its name from the weathering processes, because weathering is one of the most important and primary process that leads to rock disintegration, that breaks down rocks. So if rocks are broken down by means of mechanical weathering, then the resultant material gives birth to what we refer to as mechanically formed sedimentary rocks. From drying out and consolidation of sands, mud, clays, gravel, e.g. shale and clay, mudstone, these are mechanically formed sedimentary rocks. Mudstone, sandstone, tillite, and conglomerate. Riverine deposits, for example, glacial deposits are mechanically formed sedimentary rocks because sand, which is a riverine deposit, is broken material from somewhere else and carried by water and deposited in the river valley. So sand is a mechanically formed sedimentary rock. There is no change in the chemical composition of the rock material. Then we have organically formed sedimentary rocks. These ones are formed from remains of once living organisms. They are either carbonaceous or calcareous in nature. For example, limestone and coal. This is under organic weathering. You know very well that limestone is formed from coral polyps or once living organisms. These coral polyps, when they die, their shells are deposited on the seafloor, and because of their richness in calcium carbonate, they are cemented together to form a rock mass, which we refer to as coral reefs. And these coral reefs are rich in limestone. Then we have chemically formed sedimentary rocks. These chemically formed sedimentary rocks form from processes of chemical weathering, where we have precipitation of rocks in solution by chemical reactions and evaporation of water. An example of a chemically formed sedimentary rock is rock salt, the one which is mined in Lake Katwe. That during cold weather, the material, the rock minerals, dissolves with the water. But when the temperatures are too high, the water evaporates, leaving behind the salt precipitate or the solute. That is later mined by these miners. So, in other words, there is solution weathering in this case, that water dissolves the minerals, and so you have a solution. But when the temperature rises, the water evaporates and leaving behind a solid mineral. This is the same case as the dew crust, which is formed in the arid areas as a result of capillary upward movement of water by capillary action. The water is moving from the lower layers of the soil, dissolving minerals within the soil layers. But as the water approaches the surface of the earth, the temperatures are too high, so the water escapes by means of evaporation, depositing the minerals just below the surface of the earth, leading to the formation of the dew crust, which usually refer to as the calcrete or the ferric crust, depending on the material that dominates that dew crust. These are some of examples of sedimentary rocks. For example, limestone, we have conglomerate, we have sandstone, we have coal. These are some of the examples of those rocks. And then the last type of rocks is metamorphic. And metamorphic, these are rocks which are also formed from pre-existing rocks, changed by means of great pressure and heat. Hence the word metamorphic, because there is a complete metamorphism of the existing rock, that a rock changes completely from its original form to another form. Hence all types including earlier metamorphic rock. It can also be any earlier metamorphic rock which is changed into another form. The texture and composition of the original rock are altered by pressure associated with earth movements such as folding and heat caused by intrusion of molten rock. So you realize that after metamorphism has taken place, rocks change to other types. For example, granite changes to gneiss, sandstone changes to quartzite, clay, which is sedimentary, changes to slate, shale changes to schist, limestone, which is sedimentary, changes to marble. And so you have that classification of rocks. Rocks changing from one form to another completely under great heat and pressure. I usually give people the analogy of, for us here in Uganda, we make bricks out of clay minerals or clay soil. Or some in Uganda here is just soil, any form of soil, because the Uganda soils have higher content of clay. So people make bricks. But you get soil, you mix with water, make a brick out of it, put it under the sun, dry. That dry brick is still clay. But when you get it and put it under a pile and then you set fire, what we call baking these bricks, the baked brick is no longer clay. It's a slate. And if you want to change that slate back to clay, it will not happen. Because in this process of making bricks, you can get your bricks and put them back. These ones, the broken ones, put them back in the water, make create the soil again for afresh, and make a fresh brick. But out of the baked bricks, those ones which are broken, those were not put to use, because you cannot take them back to the process and say, let me make new bricks out of them, because they have been completely metamorphosed. The same way happens when you get wood and put it underground, put fire to make the coals. Completely metamorphosed. You cannot put back this coal, this charcoal, back to wood. No way. So those are the rocks. That's the classification of rocks depending on their mode of formation. But if we are to classify rocks on the basis of age, then we shall classify them as Cainozoic, as Precambrian, as Mesozoic, and the Paleozoic. We have rocks which are too old that were formed in the Precambrian era. We have rocks that were formed in the Paleozoic era. We have rocks which were formed in the Mesozoic era, and then we have the younger rocks which have been formed in the recent era, that is the Cainozoic era. So that is the classification basing on the geologic time scale. But the ones which we usually, I know which you have studied from high school and whatsoever, is the basis, or is the classification on the basis of mode of formation. And so that is what I wanted to give you today. Next time I'll be giving you information on continental drifting, plate tectonism, and the seafloor spreading as far